Now, when we talk about the structure, we talked about the class diagram. Now, how can we define the classes from the problem statement? And we talked about classes that code, right? The class we write in the code, and then how we describe these classes in the code in a diagram. Now, there's a step before that, which we didn't write any code or anything. We're just trying to understand the problem, and we're trying to describe it as set of classes and relationship with them. So we're trying to create a structural model from the problem, not from the code. So classes, when we talk about the classes, they are whatever is important for you on the system. Okay, so it could be, classes could be represent people. So if you're at a university, you have students as a class, you have faculty as a class, administrator as a class, could be, all right? It could be places or things like locations, addresses, or things like tables, chairs, cars, okay? Any important concept, sometimes it doesn't have to be a tangible thing. It's a lot, it can have a logical concept, something like membership. So membership is not tangible, but it can be a class in itself as well, because it's a logical concept. So when you are looking at the problem statement, you want to turn what you see, what is important in the problem, into a set of classes. And obviously, not every aspect about the concept in the real problem is important for you when you code, right? So when you have a class like a student, a class like a student in a registrar system is not necessarily the same as a class student in an LMS system, right? So in a learning management system, you might need to look into some aspects or some details or some data related to the students are not exactly the same as the data about the students that you need to keep track of in a registrar system. All right, so when you map the concept from the real world into the data model, you just capture the aspects that are important for that system. And we'll talk about the data aspects. Okay, so the data aspects of the system are the attributes, the concepts are the attributes, and any processing that happen on this data are the methods. Okay, it's not actions done by the person in real life. The behavior of the class that represents the person or the concept in the solution is not a behavior like an action that the real concepts do in real life. So if you have a real life, you're a car agency. Okay, so a car is a concept that would be part of the problem domain, right? Now, depending on what you're writing the system for, the data that you collect or keep track of about the car would be determined based on the purpose, and the actions or the behavior of the class that would be called car is not necessarily the same as the behavior of the car itself. Now, I see people creating a class car, and then car stop. The behavior of the class would be stop, run, speed, slow down. I mean, if you are creating an animation that has a car that actually speeds up and stops, then may be all right. But if you are creating an accounting system, then all this is irrelevant. Stop and speed and stopping and running and all that is not relevant. The data that would be relevant to the accounting system would be the price and the behavior that is the processing that happened on this data, maybe calc taxes, maybe offer discount. Okay, so when we are mapping the concept from the real problem for the real world to the solution domain or create a class diagram, we just capture the aspect that makes sense to the system we're trying to create. Okay, you're trying to create a system for accounting, you talk about prices and processing of the prices. Okay. Now, okay, just I'll finish this slide, and I don't know. I didn't want this to spill to next week. Can we just take 5 minutes to finish it? Okay, let's see. So just a heuristic, a general heuristic. How would you identify classes in the problem? If, generally speaking, you talk about the nouns. Nouns are good candidates for a class. Verbs are good candidates for a behavior or an action, or it could be a relationship. Okay. Sometimes if you are creating a well-known system or well-known type of system, you may have common lists of objects that belong to this system. If you are creating accounting, that's a lot of people trying to create an account system. So you will find a list of classes that need to be included. All right. And if you have, sometimes you have, when we talk, for example, about courses or course management, it goes without saying that you need students and you need courses and you need faculty and you need classes and stuff. Okay, so that gives you a first cut, an initial set of classes that you can start with, and then later on you can refine it, and usually it is an iterative process. Okay, so can we quickly try to identify classes from this? What would be the main concept in this problem that would make sense to be a class in the system that we're trying to write? Yes. A membership, obviously, this is a central concept that we need to include. Yes. A member, so the customer or the member. Yeah. Anything else? Yes. Type. Oh, so game. A game is a product, right? So game. Yeah. So product is a general class, and a game would be one of the objects there. And then an attribute of that game would be the type. Yeah. Any other classes that we can like any important concepts? Yeah.
Would video gaming have its own like class within the class? Would it have a child class or a type of video game everything in it, or is it just attributes within the class?
So that depends on how. Okay, you can have a class called game, and then a subclass that would be a subtype of game only if you need it. So remember when we have inheritance. When do we need to add a class subclass? When there is extra data or extra behavior that needs to be included as part of this class, right? Like employee and manager. So we have employee, that is a general employee class. Now, when did we need to create a subclass manager? Because the manager had a different processing for the salary, and it has an extra data that it was the bonus, right? So if the general description of the game class is not sufficient to work with all types of game, then you can create a subtype of the game class. If it's sufficient, then it's fine. And when we say subtype, okay, there's the word type that's coming from the domain that is the game type itself, right? When we talk about a class as a type, and then there's subtype of it, that's different use of the word type, right? It is a little bit confusing. So game type as the description, as the attribute that we're describing here, could be just an attribute, a field inside the class. Now, if you need some extra processing that happen on a particular type, then you can create a subclass for it. Okay. All right. So this is the what I came up with. So we have a service and we have a member. Okay, so these are the most obvious. So the service is pretty much the product, and we have a member. Now, this membership it was added as an additional. So the first two, I first came up with member and service. Now, when you link a member to a service, where would you put the quantity? If we're not going to put this membership cost, where would you put the quantity? Yes.
How many times?
So when you have a service like coffee, monthly coffee, and you have a member Jack, member John, member Alice, Now we want to say Jack subscribes in a service called coffee. You put the quantity for Jack in coffee.
No, put it.
Okay, so if Jack wants coffee and cigarettes, so which quantity is it?
Yeah.
How one will reach in one object? So we have one object for that member, right? So the quantity itself is an attribute that doesn't belong to the member or the service. It belongs to the relationship between them. So that's why this is necessary. Okay? Okay, well, maybe it's better that we take this next session. Hopefully it doesn't take too much time next session. Yes.
You go back to
The what? The what?
you go back to the document.
The what? This one? We made?
Yeah.
Oh, okay, so you wanna take a picture?
Yeah.
I'll post it. I'll post it now.
Like, it's more important. Oh, here.